At any point, the James Webb Telescope has captured the clearest picture of Proxima B in history, unveiling stunning discoveries about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the secrets of Proxima B and examine whether it could be the next Earth. We venture into the vast expanse of space, where a fascinating planet exists in the habitable zone of its star, Proxima Centauri. This planet is no ordinary rock. It's Earth's cousin, Proxima B, found 4.2 light-years away. It is shrouded in mystery and might one day resemble Earth, with oceans and life flowing across its surface. But wait, there's more. Proxima B isn't alone in its system. It has a single companion, Proxima Centauri C, which could reveal even more secrets. Perhaps there's another companion we haven't discovered yet. The mystery doesn't end there. Proxima Centauri emits a similar amount of energy as Earth receives from the Sun, raising intriguing possibilities. Could there be water on Proxima B's surface? Could life as we know it exist beyond our solar system? As we venture farther into space, we encounter an entire universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the Milky Way galaxy alone, the potential for exoplanets is boundless. Some even wander through space untethered to any star, like rogue pioneers. Among them, Proxima Centauri B stands out as a truly remarkable and perplexing planet. With a year lasting just 11.2 Earth days, its distance from its star is much closer than Earth's distance from the Sun. This means one side of the planet is perpetually bathed in light, while the other remains in eternal darkness. Now let's examine Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and B, 2G, and K-type stars that appear as one in the Centaurus star cluster and are the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 4.24 light-years from the other two stars, making it the closest star to our solar system. The name Proxima Centauri means the nearest star in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being the closest star to us, Proxima Centauri is invisible to the naked eye due to its apparent magnitude of 11.13, which is beyond the limit of human vision. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. While they may not emit much light, the convection process at their cores keeps them shining for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri is still debated. For one, it's a flare star, meaning it undergoes regular, sometimes extreme, flares. As a low-mass star, its habitable zone would be much closer than the Sun's, likely somewhere between 0.023 and 5 cents. But even this zone may not be as hospitable as it seems. Proxima B might not have a stable atmosphere, which is essential for maintaining conditions suitable for liquid water on its surface. Without this stability, life would be vulnerable to space weather, making it incredibly difficult for life to thrive. So, while Proxima B might appear Earth-like on the surface, it's far from being capable of supporting life. Still, many scientists continue to hold out hope. One tool that has captured astronomers' attention is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and is poised to help determine if life exists on Proxima B. However, as with everything in science, things are never as simple as they seem. Certain adjustments were needed to ensure the James Webb Telescope could deliver accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also re-emit that light as infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation on the planet's surface and search for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet's atmosphere isn't suitable for life? The presence of an atmosphere doesn't guarantee life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere far denser than Earth's, resulting in extreme heat that would make life impossible. The mission to uncover the truth about Proxima B isn't without its challenges. While the James Webb Telescope holds promise, there are many factors to consider. With costs mounting, space experts feel the pressure to find ways to examine planets like Proxima B. Much is at stake. However, the rewards are even greater. The chance to glimpse the unknown and unravel the mysteries of a system that could harbor life is a goal any serious scientist would pursue. But can we travel to Proxima B? It's the closest exoplanet to us, which makes it a captivating possibility. It's almost like exploring our own backyard. Even more exciting is the fact that it's almost the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it a practical target for our quest for life beyond Earth. At 4.2 light-years away, it's an ideal candidate for interstellar missions. However, traveling there is no simple task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. That said, a proposal has been made involving solar sails, ultra-thin sails that could be used to accelerate a spacecraft toward the Alpha Centauri system and Proxima B along with it. This technology uses solar radiation pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. With potential speeds of 10% to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration, offering a renewed sense of hope that we are not alone in the universe. A thick, poisonous climate. Yet get this. The James Webb Telescope can recognize such circumstances, assuming they reach a brightness of only 5% of the planet's day side. While 5% may not seem like much, it's very significant when dealing with a star that is generally dimmer than our Sun. Assuming Proxima B has intelligent life, they might be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are endless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, some being huge gas giants, while others resemble our own Earth. One type of exoplanet that has captured the attention of space experts is the gas giant. These planets are similar in structure to Jupiter and Saturn but are much larger. Some of these behemoths have been named super-Jupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching environment with temperatures high enough to melt metal. Imagine being able to observe such a planet up close, with its violent storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres difficult to study from afar. However, we must not overlook Earth-like exoplanets, those that resemble our own Earth. These planets come in various sizes, from smaller than Earth to twice its size. There are also super-Earths, which have masses greater than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets discovered recently is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a potentially Earth-like exoplanet, meaning it could actually support liquid water. Scientists believe it might be habitable, especially considering its proximity to its host star. Proxima B's potential to support life has made it the subject of intense study. Despite sitting within the habitable zone of its parent star, many uncertainties still surround its atmosphere and overall habitability. One of the major challenges for Proxima B is the intense solar flares emitted by Proxima Centauri. These flares could strip away the planet's atmosphere over time, making it more difficult for life to flourish, similar to the early stages of Mars history. The magnetic field of Proxima B would play a crucial role in protecting the atmosphere. Without this protection, the planet could face harsh conditions that prevent life from developing. Despite these obstacles, experts remain hopeful that advancements in technology, such as the James Webb Telescope, will continue to provide new insights into Proxima B's atmosphere and whether it could contain the necessary conditions for life, such as liquid water. The telescope is capable of analyzing the planet's atmospheric composition, searching for key chemicals that could signal biological activity, such as oxygen, methane, or carbon dioxide. Even if Proxima B is not habitable, the discovery of so many potentially Earth-like exoplanets in the habitable zones of distant stars opens up new possibilities for finding life beyond Earth. The search for exoplanets is one of the most exciting fields of exploration today. The vast number of stars and planets in our universe suggests that life may be more common than we think. Although we are far from reaching these distant worlds, the quest for knowledge about our universe is an adventure worth pursuing. For now, Proxima B remains one of our closest and most fascinating focal points in the search for life beyond Earth. As technology continues to advance and we delve deeper into the complex dynamics that make a planet habitable, we draw one step closer to answering one of humanity's oldest questions. Are we alone in the universe? The study of Proxima B and other exoplanets is just the beginning. The next few decades could bring groundbreaking discoveries that will shape how we understand life in the universe. As we continue to push the boundaries of space exploration, one of the most captivating aspects of studying exoplanets like Proxima B is the possibility that life could exist in places far beyond our own solar system. The discovery of such planets broadens our understanding of where life could thrive. Proxima B, in particular, has captured the imagination of scientists due to its proximity and potential for habitability. However, understanding whether life could truly exist on this distant world requires more than just searching for water or suitable temperatures. One area of research that has gained significant attention is the search for biosignatures, chemical markers that could indicate the presence of life. In Earth's atmosphere, gases like oxygen and methane are produced by biological processes, and their presence in the atmosphere of an exoplanet could suggest similar biological activity. The James Webb Space Telescope, with its advanced capabilities, is designed to study the atmospheres of distant exoplanets in unprecedented detail. By analyzing the light that passes through Proxima B's atmosphere, it can detect the chemical composition and search for these key biosignatures. The challenge, however, lies in the fact that the presence of certain gases does not always guarantee the presence of life. For example, oxygen can be produced by natural processes like water splitting under ultraviolet light, and methane could come from geological or chemical processes unrelated to biology. This means that detecting these gases is only one piece of the puzzle. Scientists must carefully evaluate the context in which these gases exist, and whether their concentration and composition suggest biological origins. In addition to identifying biosignatures, astronomers also need to understand the dynamic environment of Proxima B. As a planet orbiting a red dwarf star, Proxima B faces unique challenges. Red dwarf stars are known for their unpredictable flare activity, which can significantly affect the atmosphere of nearby planets. These flares can strip away the atmosphere over time, especially if the planet lacks a strong magnetic field to protect it. This is one of the key questions regarding Proxima B's habitability. Without a stable atmosphere, liquid water could not exist, and conditions would likely be too hostile for life to thrive. In addition, red dwarfs like Proxima Centauri experience periods of high stellar activity, which can include flares that last for weeks or even days. These flares release massive amounts of radiation that could harm any potential life forms. However, this does not mean that Proxima B is completely inhospitable. If the planet has a strong magnetic field, it could offer some protection from these solar flares, much like Earth's magnetosphere shields us from harmful solar radiation. Another intriguing aspect of Proxima B is its orbit and rotation. Its year lasts just 11.2 Earth days, which means it orbits its star much closer than Earth does to the Sun. This tight orbit places it in what is known as the habitable zone, or the Goldilocks zone, of Proxima Centauri, a region where conditions might be just right for liquid water to exist on the surface. However, due to its close orbit, Proxima B is likely tidally locked to its star, meaning one side of the planet constantly faces the star while the other side remains in perpetual darkness. This could create extreme temperature differences across the planet, potentially making conditions on Proxima be more challenging for life to survive unless mechanisms like strong atmospheric circulation or a water cycle could help balance the temperatures. Despite these challenges, The discovery of potentially habitable exoplanets like Proxima B has reignited the search for life beyond Earth. New technologies like the James Webb Space Telescope offer hope that we may be able to answer the age-old question: are we alone in the universe? As we continue to refine our ability to detect exoplanets and study their atmospheres, we draw closer to understanding what makes a planet truly habitable and whether life can arise in places we previously never imagined. Proxima B is just the beginning, and as technology advances, the next few decades will likely yield even more exciting discoveries in the quest for extraterrestrial life.